Welcome to David Alexander Maths Tuition. This is chapter 11D, position vectors. So the points A, B and C have the coordinates 6, 2, 8, 5 and 12, 3 respectively. Find in terms of I and J the position vectors of A, B and C. So all we need to do is just think of how we're getting to 6, 2 from the origin. So this is so easy it's almost hard. To go from the origin to the coordinate 6, 2, we're going 6 along the x-axis and 2 up the y-axis, except here we're doing it in terms of i's and j's. So the x-axis is I, the y-axis is j. So A is just 6i plus 2j. Easy. So B is therefore 8i plus 5j, and C is 12i plus 3j. So these are the position vectors in terms of I and j of these coordinates. Okay, so the points A, B and C have the same coordinates and we want to find the vector A to B. So if I just do a quick sketch, 6 along and 2 up, this is point A, and so we know that from the origin that is 6 across and 2 up, and B is 8, 5. So this is B here. So that is 8 along and 5 up. So we want the position. We want to work out the vector A to B. Now, if we know that A is the vector, we can say that that is the vector O to A. Now O to A, that is going to be 6i plus 2j. And this is the vector OB and the vector O to B. To go from O to B, you're going 8 along and 5 up. So how do I go from A to B? Well, I go backwards to the origin and I go back up the vector OB to B. So to go A to B is minus the vector OA plus the vector OB. So we just need to remember that the vector AB, that is the vector OB minus OA. So OB take away OA. So OB we know is is 8i plus 5j, and we are subtracting O to A, which is minus 6i minus 2j. So therefore 8 take away 6 is 2i, 5 take away 2 plus 3j. But to be honest, like when you think about it logically, to go from 6 to 8, that is going to be the plus 2i, and to go from 2 to 5, you're adding the 3j. So you could say that to go A to C, well, that is simply to go from 6 to 12, so A to C, that's going to be plus 6i, and to go from 2 to 3, that is plus 1j. But we should remember that A to C, that is the vector O to C minus the vector O to A, and the vector O to C is 12i plus 3j, and we're taking away the vector OA, so minus 6i minus 2j, and that is giving us the 6i plus 1j. So for this question, we're just needing to find the magnitude of the vectors that we just worked out. So find in surd form the magnitude of the vector AB and the magnitude of the vector AC. Remember, these lines mean the magnitude. So remember that A to B, that was 2i plus 3j. So therefore the magnitude of AB, that is the square root of 2 squared plus 3 squared, and the square root of 2 squared plus 3 squared is root 13. So the magnitude of AB is root 13. So A to C, that was 6i plus 1j, so therefore the magnitude is going to be the square root of 6 squared plus 1 squared, so 36 plus 1, so that is going to be the square root of 37. So nothing new there, we're just combining two things we've previously learnt together. Okay, so O to C is 3i plus 5j and O to B is 6i minus 9j. We want to find C to B. Okay, so the vector C to B, that is the vector OB minus the vector OC. So OB is 6i take away 9j, and we're subtracting this, so we're subtracting 3i and we're subtracting 5j. 6i take away 3i is 3i, and minus 9 minus 5 is minus 14j. Okay, so again, nothing new here. Finding the magnitude of OC, well, that's just the square root of 3 squared plus 5 squared. OB, that's the square root of 6 squared plus 9 squared, or minus 9 squared, which is of course the same as 9 squared. And CB, that's the square root of 3 squared plus 14 squared. So the square root of 3 squared plus 5 squared is root 34. The square root of 6 squared plus 9 squared is 3 root 13. And the square root of 3 squared plus 14 squared, that is the square root of 205. So these surds here, these are the magnitudes of the vectors OC, OB and CB. The position vectors of 3 vertices of a parallelogram are 3, 1, 7, 3 and 5, negative 4. Find the possible position vectors, plural, of the 4th vertex. So for this question, probably worth just doing a quick sketch. So I've got 3, 1, I've got 7, 3. So let's label that as 3, 1, 7, 3, and 5, negative 4. Okay. So I think it should be fairly obvious that if I were to turn this into a parallelogram, then there would be another vertex here to create a parallelogram. But is that the only option? No. We could also put the other vertex over here, and we can see that this would also create a perfect parallelogram. So we've got 2 options. So all I would do here is I'd just be thinking about, well, to go from here, to go from the 3, 1 to the 7, 3, that is just adding, well, 4i plus 2j. So therefore, all I need to do is add, I mean, we don't even need to see it in terms of i's and j's, just use a bit of common sense. I'm adding 4 to the x's and adding 2 to the y's. We can see it in x's and y's if you want, instead of i's and j's. So therefore, this point here is going to be 5 plus 4, which is 9, and minus 4 plus 2, which is minus 2. So there's one option. So 9 minus 2. Now we know that to go from here to here is, we're just adding 4 and adding 2. So therefore, if we're here and going backwards in that direction, then we'd be subtracting 4 from the first coordinate and subtracting 2 from the second. So therefore, to go from here down to here, I need to do the same thing. So I've got 5, let's just write this a bit more clearly, take away 4, 5, negative 4, so I need to subtract 4 from the x's, so that would be 1, and I need to subtract 2 from the minus 4 to get minus 6, and on my diagram that does seem vaguely believable, but this could be 1i or 1i minus 6j, or just 1x minus 6y. So that is that's the other possible position vector of that fourth vertex, 1, negative 6. So doing a little sketch is probably the best way to do it, and to be honest, you're probably not even thinking that this is anything to do with vectors. You're just using a bit some coordinate axes and a dollop of common sense.